Best machine learning algorithms for beginners. Machine learning (ML) is revolutionizing industries by enabling computers to learn from data and make intelligent decisions. For beginners entering this field, understanding fundamental ML algorithms is crucial. This article explores the best machine learning algorithms for beginners, offering insights into their working principles, applications, and advantages. 1. Linear regression. Overview. Linear regression is one of the simplest and most widely used supervised learning algorithms. It establishes a relationship between independent variables, features, and a dependent variable target using a linear equation. How it works. The algorithm fits a straight line, regression line, to the dataset, minimizing the difference between predicted and actual values. The equation for linear regression is: where is the dependent variable? Is the independent variable? And are coefficients? Is the error term? Applications. Predicting house prices. Sales forecasting. Stock market analysis. Advantages. Simple and easy to interpret. Efficient for small datasets. 2. Logistic regression. Overview. Despite its name, logistic regression is used for classification problems. It predicts the probability that an instance belongs to a particular category. How it works. Instead of fitting a straight line, logistic regression uses the sigmoid function to squeeze output values between 0 and 1. If the probability is above a certain threshold, usually 0.5, the instance is classified into one category. Otherwise, it falls into another. Applications. Spam email detection. Credit risk assessment. Medical diagnosis, e.g., predicting disease presence. Advantages. Works well for binary classification problems. Outputs probability estimates. 3. Decision trees. Overview. Decision trees are intuitive and easy to understand algorithms used for classification and regression tasks. They split data into branches based on feature values, making decisions at each node. How it works. A decision tree consists of nodes representing features, edges representing decisions, and leaves representing final outcomes. The algorithm selects the best feature at each step using measures like Gini impurity or information gain. Applications. Customer segmentation. Loan approval decisions. Diagnosing diseases. Advantages. Easy to visualize and interpret. Requires minimal data preprocessing. 4. K-nearest neighbors (KNN). Overview. The K-nearest neighbors algorithm is a non-parametric, instance-based learning method used for classification and regression. How it works. KNN classifies a new data point based on the majority class of its K closest neighbors in the feature space, typically using Euclidean distance. Applications. Recommender systems. Image recognition. Medical diagnosis. Advantages. Simple and intuitive. Works well with small datasets. 5. Support vector machines (SVM). Overview. Support vector machines are powerful supervised learning models used for classification and regression. They work by finding the best boundary, hyperplane, that separates data points of different classes. How it works. SVM maps input features into a high-dimensional space and finds the optimal hyperplane that maximizes the margin between different classes. Applications. Handwritten digit recognition. Text categorization. Fraud detection. Advantages. Effective in high-dimensional spaces. Works well with small to medium-sized datasets. 6. Naive Bayes. Overview. Naive Bayes is a probabilistic classifier based on Bayes' theorem. It assumes that features are independent, simplifying computations. How it works. The probability of a class given a set of features is computed as applications, spam filtering, sentiment analysis, medical diagnosis. Advantages. Works well with categorical data. Fast and efficient for large datasets. 7. Random forest. Overview. Random forest is an ensemble learning algorithm that builds multiple decision trees and combines their outputs for better accuracy. How it works. It randomly selects subsets of data and features to build multiple trees. The final prediction is determined by averaging, regression, or majority voting classification among trees. Applications. Credit scoring. Fraud detection. Healthcare diagnostics. Advantages. Reduces overfitting compared to single decision trees. Handles missing values well. 8. K-means clustering. Overview. K-means is an unsupervised learning algorithm used for clustering data into K-groups based on similarity. How it works. The algorithm iteratively assigns data points to the nearest cluster centroid, then recalculates centroids until convergence. Applications. Customer segmentation. Image compression. Anomaly detection. Advantages. Simple and scalable. Efficient for large datasets. 9. Principal Component Analysis (PCA). Overview. Principal component analysis is a dimensionality reduction technique used to transform high-dimensional data into a lower-dimensional form while preserving variance. How it works. PCA identifies the direction's principal components that maximize variance and projects data onto them. Applications. Image compression. Noise reduction. Feature selection. Advantages. Reduces computational complexity. Improves visualization of high-dimensional data. 10. Gradient boosting machines (GBM). Overview. Gradient boosting is an ensemble learning method that builds models sequentially, improving performance by correcting previous errors. How it works. It builds weak learners, usually decision trees, and combines them using gradient descent to minimize prediction errors. Applications. Predictive analytics. Financial modeling. Healthcare diagnostics. Advantages. High accuracy. Works well with structured data. Conclusion. For beginners in machine learning, understanding these algorithms is a crucial first step. Linear and logistic regression provide fundamental insights, while decision trees and KNN offer intuitive learning. As proficiency grows, more advanced models like random forest and gradient boosting can be explored. Each algorithm has its strengths and best fit scenarios, making it essential to choose the right one based on the problem at hand. With practice and experimentation, mastering these algorithms will lay a solid foundation for a successful career in machine learning.